We're going to look at doing operations and functions. Now, adding, subtracting, multiplying, dividing functions, and then putting functions within functions called composition of functions. So just to help you remember what a function is, suppose you are working for a company and you're making $11.50 an hour. You know the more hours that you work, the more money you earn. We could write this in function notation. We could say your earnings, which is based on your hours, is equal to 11 and a half times your hours. Or if we didn't want to use full words, we could go E for earnings and H for hours and to shorten it up. Now, your E here refers to your name of your function. H is your input, and what's over here on the right-hand side tells us what we're doing with that input to be able to get our answer. So that's what function notation is. What's in front is your name, what's in the parentheses is your input, and what's on the right-hand side here is the rule of what you're doing to that input. So if we're looking at functions here, we're having our f function, our g function, we're asked to add them together, f plus g. So you take your red plus your blue, and then all you have to do is add your like terms together. In this case, 3 of the x squareds plus 1 more of the x squareds is 4 of the x squareds. No other like terms, you just bring them down. Over here, we're taking our red f and we're subtracting our blue g. So we'll write it that way. However, because we're dealing with subtraction and the order in which you subtract makes a difference, we need to put parentheses around our whole g function. Then we could distribute through that negative into the blue, and then we could go ahead and collect like terms. 3 of the x squareds minus 1 of the x squareds is 2 of the x squareds. Then just bring down the rest of your terms because there's no like terms. The dot in between your f and your g down here is just multiplication. So we got to take our red f times our blue g. We'd have 2 terms times 2 terms, and we just have to FOIL. We'd multiply together your first terms, your outer terms, your inner terms, your last terms. We have no like terms, so we don't do anything. F divided by g, because the fraction bar means divide, so we take the top f divided by the bottom g, and that's really it. The only thing we should do is go ahead and indicate what we can't use. Now, on our first 3 answers, we're not dividing by variables. We have no variables in roots, no variables in square roots or anything, so it doesn't make a difference what we're doing. Now, initially, we had that here for g, that we could use any number we want. But now we can't use certain numbers because we know we can't divide by 0. So on the side, you need to go ahead, set the bottom equal to 0, and indicate what numbers we cannot use. And in this case, if we solve that, we're trying to figure out what we cannot use. So basically, we set it equal to not 0, solve it. Now we take our square root, and we get x to be plus or minus 1. And so that tells us what we can't use. So this whole thing would be our answer. Now, some of you do enjoy shopping. Some of you may have even shopped at Kohl's. Now, it's common if you go to Kohl's that you get Kohl's Cash. And it's common to get a coupon for Kohl's in the mail. Now, suppose you had $10 off in Kohl's Cash and you had a coupon for 20% off. By the way, if you had a coupon and 20% that you didn't have to pay for, you're paying for 80%, so that's why we have 0.8 for your coupon function. Your Kohl's Cash says, I don't care what you have for a price, I just subtract $10 because you had $10 in Kohl's Cash. Typically at Kohl's, you can use your coupon and your Kohl's Cash on a purchase. So suppose you had an initial purchase of $120. Does the order in which you apply these discounts make a difference? So suppose you did your coupon first and then subtracted your $10. Or suppose you subtracted your $10 and then you did your coupon, because you can often do both. So if you did your Kohl's cash, you'd subtract $10, and then we'd do our coupon, so that would be multiplying by 0.8. So you subtract your $10 first, and then you multiply by that 80% of the price that you're paying because it was 20% off. So if we plug in our 120 for our X, subtract your $10, multiply it by 0.8, we get $88. Suppose you did your coupon and then you subtracted your $10. So here you'd be doing your coupon of 80% of your original price is what you're paying for. Then after that, subtracting your $10. So it'd be 0.8 times 120 minus 10, and that's $86. So the order in which we apply our discounts does make a difference. By the way, you would probably prefer Kohl's to give you this price. They're actually going to give you this price because they know it's better for them. If you know the math, you know there's a difference, but most people don't realize that there would be a difference. So that's really putting one function into another function. That's what we're going to look at here. So when you have f of g of x, that means you're taking g and plugging it into f. Or if it was the other way around, you'd be taking the inside of f and plugging it into g. So just to review, if you're looking for f of 2, you got to go to function f and plug in 2 for each one of your x's. And then you work that out, and you would get 28. Now, if you had f of triangle, you'd go up here to f and plug in triangle for each one of your x's. So it'd be 3 times triangle squared plus 7 times triangle. Or if it was f of box, it would be 3 box squared plus 7 box. So if it's f of g, well, g is that x squared minus 1. We'd still have to go to our function f because that's what's in the outside, which is 3 times your input squared plus 7. That's what the rule says, 3 times input squared plus 7. Our input here is what's in our parentheses, which is the blue of an x squared minus 1. So I got to put an x squared minus 1 in for each one of my inputs. So now all I have to do is work this out. Here I could distribute through my 7, but here squaring means multiplying by itself, so it'd be an x squared minus 1 times another x squared minus 1. So if you FOIL that out, you get this here. Then you can distribute through your 3, then collect your like terms after that, and you get this. Over here to review, suppose you had g of 3, you go to function g, which just says input squared minus 1. So our input's 3, so 3 squared minus 1, which we know is 8. So g of triangle is input squared minus 1. G of box is box squared minus 1. So g of f of x would be g of what f is, which is this. Now, once again, g says whatever your input is, you need to square it and then subtract 1. That's what g says to do, input squared minus 1. So we have input squared minus 1. Our input is this whole red thing. So that's what it would be, because f is what's going into this one here. So now, to work this out, we'd have to go ahead and square this, which would be 3x squared plus 7x times another 3x squared plus 7x. We'd have to go ahead and FOIL that out, then subtract 1 afterwards, collect our like terms, and we would get this.